morning, Mr. Teo and our fellow buddy group. Today we will be sharing with you our experiment involving alkaline cleaning agents. Household cleaning agents like detergents are extremely useful to us as they help break down mineral deposits, algae and food stains. However, given their strong pH properties, they are capable of destroying the layers of our skin when they come into contact with it. Families with toddlers and infants are particularly at risk as young children have much more sensitive skin. Thus, we plan to find out what kind of cleaning agents families should keep away from themselves so as to prevent any burns or chemical injuries. We tested two alkaline cleaning agents, FairPrice Pipe Decocker, which is Agent A, and Jackie Liquid Drain Opener, which is Agent B. We reacted each of them with the Magiclean Toilet Cleaner, which contains citric acid. We hypothesized that Agent A will be more harmful to the skin as compared to Agent B.
For the experiment, we used two styrofoam cups with an insulation lid, a microbit, 3 pots for DIY distillation, a measuring cylinder, and an electronic balance. Step 1. We diluted equal amounts of Magiclean Dual Power Toilet Cleaner with water, giving us FA1. Step 2. We diluted equal amounts of Agent A with distilled water, which gave us FA2. Step 3. Using a measuring cylinder, we poured FA1 into a styrofoam cup. Step 4. We used the microbit's thermistor to record the initial temperature of FA1. Step 5. We poured 10 cm3 of FA2 into the solution of FA1 and covered the styrofoam cup with an insulation lid. We stirred the mixture and recorded a highest temperature rise using a microbit thermistor. And lastly, step 6. We repeated steps 2 to 5 for the cleaning agent B. And to ensure reliability of our test, we repeated the experiment 3 times and got the average reading.
So we made these 3 assumptions over here for our calculations. Firstly, we used the microbit data to find delta T for cleaning agent B. Using the equation Q equals to mc delta T, we found that the heat evolved from the reaction solution. We then used the equation delta H equals to negative Q over N to find the number of moles of water produced. And using the molar ratio from the chemical equation, we found the number of moles of citric acid in the cleaning agent. The concentration of hydronium ions is approximately the same as the concentration of citric acid, as the concentration of hydronium ion is only 1.48 minus Z, where Z is only 4% of 1.48. Using the pH formula over here, pH equals to negative log hydronium ion concentration, we found the pH to be 2.8. As the volume of acid and alkali are equal, we let X be the pH of the alkali, giving us the equation 2.8 plus X over 2 is equals to 7, where X is 11.2. Therefore, the pH of alkaline cleaning agent B is 11.2. We repeated these calculation steps to find the pH of alkaline cleaning agent A, which gave a pH of 10.98.
In terms of limitations for our experiment, there was heat loss that we couldn't entirely prevent. Also, there were some other components in all of our reactors that may have affected the main reaction between citric acid and sodium hydroxide. However, we took this into consideration when choosing our reactants, and the 3 reactants we used in the end are those that contain the least secondary components. To ensure our safety, we also made sure to wear gloves and goggles throughout the experiment, as our reactants were corrosive. We also ensured that there were no exposed wires from the microbit before starting so as to prevent electrical injury. Based on our calculations, since both cleaning agents have a pH well above the human skin tolerance of pH 4.7 to 5.75, we concluded that both are dangerous when in contact with human skin and should be avoided, especially around children. Thank you.
What difficulties did your group face during the procedure and how could they be improved?
On our first try, we used a plastic container with an open lid, and this may have caused significant heat loss in our experiment. So we switched to a styrofoam cup with an insulated lid for our second try, with a hole in the top for the microbit thermistor. This ensured that heat loss was minimized and our results were accurate.
Hi everyone, we are Group 1 and we are providing feedback for Joey's group. So firstly, we would like to commend their effort because they considered the purity of the reaction. They took the purity of the reactants into account and chose the more pure substances, including using an acidic cleaning agent so the citric acid concentration was higher.
Secondly, the poster was really nice and neat and very well organized, but we feel that they can try to include their results in like a table or graph format so that we can see the evidence that they are using. Since the poster itself is quite limited.
I think what they could improve on is maybe showing a graph on like their temperature change and like their temperature formula, because there's no evidence to substantiate their claim. They also didn't say why they think FairPrice Decocker is more harmful in their hypothesis.
Overall, it was good, and the calculations were very good. I think the use of